The C-17 Globemaster III can swallow 3 Apache helicopters whole, fly them halfway around the planet, and land on a dirt strip shorter than most Walmart parking lots. Sounds impossible. Right. China's been trying to copy it for 2 decades. Russia gave up. Europe? They built something close, and immediately realized why America charges $218 million per plane. So what makes this flying warehouse so stupidly difficult to replicate? Stick around, because the rabbit hole goes deeper than you think. Let's get one thing straight. The C-17 isn't the biggest military transport, which is basically a flying stadium. The C-17 isn't the fastest either. But here's the thing. The C-17 does something no other aircraft on Earth can pull off. It combines the carrying capacity of a heavy lifter with the agility of a tactical transport. It's like having a semi-truck that can do parkour. Picture this. You need to move an Abrams tank. That's 68 tons of American steel and attitude. Most cargo planes can lift it. Sure. But landing, that's where things get spicy. The C-5 needs a runway longer than the Golden Gate Bridge. The Russian An-124? Same problem. The C-17? It'll drop that tank on a gravel strip in the middle of nowhere and be wheels up before the dust settles. Now you're probably thinking, okay, it's a good plane. Why can't anyone copy it? Here's where it gets interesting. Because the C-17 isn't just one innovation. It's 7 different engineering breakthroughs wrapped in aluminum and stubbornness. Each one hard enough to make rival nations weep into their vodka. Let's start with the wings. And no, I'm not talking about the things that keep it in the air. Obviously, I'm talking about a specific design choice that Boeing's engineers made that seemed insane at the time. The C-17 uses what's called a supercritical airfoil. Right. Here's what it actually means. Most wings are designed to keep air flowing smoothly over the top and bottom. When you go fast enough, that air starts hitting the speed of sound, creating shock waves that destroy lift and make your plane handle like a drunk elephant. The supercritical airfoil delays that problem, letting the C-17 cruise at speeds where other cargo planes start shaking themselves apart. But wait, there's a catch. Always is. This type of wing is incredibly hard to manufacture. The tolerances are measured in fractions of millimeters. One tiny imperfection, and the whole aerodynamic profile falls apart. China's been trying to master this for their Y-20 transport. They got close enough to make something that flies. But close isn't good enough when you're trying to land on questionable runways in hostile territory. Now let's talk about those engines. 4 Pratt & Whitney 4-117 turbofans, each putting out 40,440 pounds of thrust. Do the math, and that's 161,760 pounds of raw pushing power. But thrust isn't the impressive part. Lots of engines make thrust. The C-17's engines do something weird. They're mounted high on the wing, with the exhaust blowing over massive externally blown flaps. When the pilot drops those flaps, the engine exhaust gets redirected, pushing down and creating what's basically a second source of lift. It's the aerodynamic equivalent of cheating on a test and still learning the material. This system lets the C-17 approach at impossibly steep angles, dropping like a brick with control. Normal cargo planes need to come in shallow and slow, eating up runway like it's going out of style. The C-17 can drop into spaces that would make other pilots file a complaint with their union. Russia looked at this design and said, nah, too complicated. Their Il-76 uses conventional engine placement and hopes for the best. China's Y-20? They tried to copy the engine mounting. They got it half right, which in aviation is the same as getting it completely wrong. But engines and wings? That's just foreplay. The real magic happens in the landing gear. And I'm not exaggerating when I say the C-17's landing gear is a masterpiece of engineering that makes grown aerospace engineers weep with joy. Most cargo planes have landing gear designed for nice, smooth, reinforced concrete runways. The kind of runways that take months to build and millions to maintain. The C-17's gear is designed to land on dirt, gravel, sand, and apparently sheer willpower. Each main landing gear has 6 wheels. That's 24 wheels total, not counting the nose gear. Those wheels spread the aircraft's weight over a huge area. An empty C-17 weighs 282,500 pounds. Loaded to max capacity, it tips the scales at 585,000 pounds. That's heavier than a blue whale. The landing gear spreads all that weight so effectively that the plane can land on runways with a California bearing ratio of only 6. For the non-engineers in the audience, that's basically hard-packed dirt. But here's where it gets stupid. Each of those landing gear assemblies is semi-independent. They can absorb different shock loads, handle uneven terrain, and compensate for runways that have more bumps than a teenager's face. The hydraulic system managing all this is so complex it requires its own computer system just to keep everything synchronized. China tried to copy this. They really did. But the materials science involved, the hydraulic control systems, the computer integration, they're years behind. Maybe decades. Russia didn't even try. They just accepted that their transports need real runways and called it a day. Now let's talk about the cargo hold. Because this is where the C-17 goes from impressive to borderline supernatural. The hold is 88 feet long, 18 feet wide, and 12 feet 4 inches tall. You can fit 3 Stryker vehicles in there, or 1 Abrams tank and still have room for support equipment, or 102 paratroopers with full combat loads, or 36 litter patients with full medical teams, or 170,900 pounds of whatever needs to go from here to there right now. But size isn't the trick. The trick is the floor. The entire cargo floor is a powered roller system, pull-lock, or provide restraint points for cargo. Loading an Abrams tank isn't a gentle process. It's 68 tons of metal that needs to roll up a ramp, into the hold, and get secured without shifting an inch during flight. The C-17 can do this in 15 minutes. Most other cargo aircraft need ground equipment, careful positioning, and prayer. The C-17's floor system and ramp design mean you can drive vehicles in, lock them down, and be airborne before your coffee gets cold. China's Y-20 has a cargo floor. It has rollers. But the system isn't nearly as sophisticated. Loading times are longer. Weight distribution is trickier, and the ramp angle on the Y-20 is steeper, making it harder to load heavy vehicles without scraping the belly. Speaking of the ramp, let's discuss something that sounds boring but is actually mind-blowing. The rear cargo door and ramp system. This isn't just a door. It's a hydraulically operated platform that can function as a ramp for loading, a door for in-flight operations, or both simultaneously. The C-17 can fly with the ramp down, totally open. At altitude. This means you can airdrop cargo or paratroopers without landing. The ramp can handle the aerodynamic forces, the hydraulic systems can maintain position, and the flight control computers can compensate for the massive change in the aircraft's aerodynamics. Try that with most cargo planes and you'll rip the ramp clean off or lose control of the aircraft. The engineering required to make this work involves materials that can handle extreme stress, hydraulic systems powerful enough to fight hurricane-force winds, and flight control computers sophisticated enough to keep the plane stable when its entire rear end is hanging open like a barn door in a tornado. Europe's A400M can do this. Barely. It works. But the system is finicky and has strict operational limitations. China's Y-20? Nope. The ramp stays closed during flight, or the flight stays on the ground. Russia's Il-76 can technically open in flight, but the operational envelope is so limited it's basically a party trick. Now let's talk about avionics. The C-17's cockpit looks like it was designed by people who actually fly planes. Revolutionary concept, I know. It uses a digital fly-by-wire system, meaning there's no direct mechanical connection between the controls and the flight surfaces. Everything is electronic, managed by computers that constantly monitor hundreds of parameters per second. This system gives the C-17 handling characteristics that should be impossible for a plane this size. It can pull maneuvers that would make other cargo aircraft break into pieces or simply refuse to respond. The flight control computers prevent the pilots from exceeding structural limits while still giving them incredible precision. Pilots say flying the C-17 feels more like driving a fighter jet than piloting a cargo plane. You can bank hard, climb steep, and maneuver in ways that make passengers question their life choices, all while carrying 170,000 pounds of cargo. They use it in their fighters, but scaling it up to a massive transport aircraft while maintaining the same level of control and reliability. That's a different beast. The Y-20 has digital controls, but they're more conservative, less responsive. It flies like a cargo plane, because that's what the computers allow it to be. Here's something most people don't think about. Maintenance. The C-17 was designed from day one to be maintained in the field with minimal equipment. You can swap an engine in under 24 hours with a small crew and basic tools. The modular design means components can be replaced without specialized facilities. This matters because military operations don't happen at convenient locations with full maintenance hangars. The C-17 can operate from remote bases, deployed locations, and places where the nearest hangar is on another continent. It's built to be fixed by people who are more concerned with getting the mission done than following the perfect maintenance procedure. Replicating this philosophy requires rethinking how you design every single system. It's not just about making things work. It's about making them work when everything else has gone wrong. In places where Murphy's Law is the only law that matters. By people who are tired, stressed, and possibly under fire. The Soviet design philosophy was different. Their planes were tough, sure, built like tanks. But maintenance required specialized equipment and facilities. China's learning this lesson the hard way. The Y-20 needs more support infrastructure, more specialized tools, more time on the ground between missions. Let's talk about something that doesn't get enough attention. Fuel efficiency. Yeah, I know. Fuel efficiency in a military transport sounds about as exciting as watching paint dry. But hear me out. The C-17 can fly 2,400 nautical miles with a full 170 900-pound payload without refueling. That's roughly the distance from New York to Las Vegas. With max fuel and a lighter load, it can stretch that to over 5,200 nautical miles. That's New York to London, with room to spare. This range comes from incredibly efficient engines, optimized aerodynamics, and fuel management systems that squeeze every mile out of every gallon. The plane can cruise at 450 knots at 28,000 feet, or throttle back for maximum endurance. The flight management computers constantly calculate the most efficient profile for whatever mission you're flying. China's Y-20 has decent range. On paper. In practice, it burns more fuel for less distance with comparable loads. The engines aren't as efficient. The aerodynamics aren't as clean. Small differences that add up to mission-critical gaps. Now here's where things get really interesting. The C-17 program almost didn't happen. In the 1990s, the Air Force was debating whether they even needed a new transport. The C-5 could lift more. The C-130 could land anywhere. Why spend billions developing something in between? The answer came down to one word: flexibility. The military realized that future conflicts wouldn't wait for perfect conditions. They needed something that could haul strategic loads but operate in tactical environments. Something that could fly from Dover Air Force Base in Delaware and land on a dirt strip in Afghanistan without breaking a sweat. Boeing delivered that capability. But it cost them. Development was plagued with problems. Delays. Cost overruns. Technical challenges that seemed impossible. The first production aircraft flew in 1991, but it took years to work out all the bugs. The program almost got canceled 3 times. China watched all this. They saw the mistakes, the solutions, the final product, and they thought, we can do that. We'll just skip the mistakes part. Turns out you can't. Every one of those mistakes taught Boeing something crucial about how to build this type of aircraft. China's trying to learn those same lessons, except they're starting from scratch and missing key pieces of the puzzle. The Y-20 first flew in 2013. It entered service in 2016. On paper, it looks competitive. Similar size, comparable payload, decent range. But in practice, it can't do what the C-17 does. It can't land on rough fields. It can't operate with the same efficiency. It can't be maintained with the same ease. And this isn't a knock on Chinese engineers. They're brilliant. They've built some incredible aircraft, countless improvements, and lessons learned from flying missions in every hellhole on the planet. That's not something you can copy from satellite photos and stolen blueprints. Russia's in an even worse position. They have the An-124, which is massive but needs perfect runways. They have the Il-76, which is tough but old. They've talked about developing a new transport for decades. Nothing's materialized, because they looked at what it would take to match the C-17 and decided their money was better spent elsewhere. Europe's A400M comes closest. It's a genuinely impressive aircraft, that can do most of what the C-17 does. But it's smaller, carries less, and costs nearly as much. The development was a nightmare that went years over schedule and billions over budget. And even now, it still can't quite match the C-17's combination of capabilities. Here's the thing that really drives the point home. The U.S. Air Force operates 222 C-17C. They're the backbone of strategic airlift. They've flown missions in Iraq, Afghanistan, Libya, Syria, and dozens of humanitarian operations. They've landed in places that don't deserve to be called runways. They've been shot at, hit by ground fire, and kept flying. The operational tempo is insane. These planes fly constantly. They're everywhere, all the time, moving cargo that needs to be somewhere yesterday. And they keep working. The mission-capable rate hovers around 85%, which is incredible for aircraft. This complex flying this hard, China has built maybe 50 Y-20 sets in. They're still working out operational procedures, still training crews, still discovering all the things that don't work quite right. They'll get there eventually. But eventually isn't good enough when you need global reach right now. The C-17 isn't just a plane. It's a system. Trained crews, maintenance infrastructure, and institutional knowledge built over 3 decades of constant operations. You can't clone that. You can build something that looks similar, flies in a vaguely comparable way, and technically meets the definition of a strategic transport. But you can't replicate the whole package. Not quickly. Maybe not ever. Because by the time you catch up to where the C-17 is today, Boeing will have incorporated another decade of improvements and lessons learned. The target keeps moving. That's why this insane transport is impossible to clone. It's not one thing you can copy. It's 10,000 small things that all have to work perfectly together, backed by experience you can only gain through years of operational reality. China will keep trying. Russia might try again. Europe's got their version. But there's only one C-17. And that's exactly how the U.S. Air Force likes it.